All right, looks like we are live. Hello,
Yeah.
everyone.
Hello.
Hey, Daniele. Uh, Good morning, good afternoon, good evening, wherever you are joining us from the world. Today, we have Daniele presenting enforcing policies across multi-tenant Kubernetes at scale. And this is the last session of this year's multi-tenancy March. If you're looking to watch the previous sessions, and if you have already registered, I will send an email so you will get everything. You can watch the YouTube recordings and everything. And before I hand over to Daniele, just a few housekeeping items. If you have any questions, keep them coming in the comment section. We will get to the questions at the end. And with that, uh, I think we are ready to roll. Daniele, over to you.
We are. Thank you very much, Rahul. Thank you for the intro. I am still missing Mike. I'm sorry, Rahul.
No, no,
No one wants to be harsh.
I miss
No,
him too, but
I it's been a long way, and I miss him. But anyway, thank you very much for having me, and thank you very much for all of you who are joining us today. Um, I shared my slides. Raul, do you mind just, I don't know how it's done. Do you mind just making them appear on the screen? Yes, thank you very much. So today we are going to talk about enforcing policies. So as usual, I like to focus on the basic, on the foundational. So we will start with that. So a few words about me to start. Oops. Yes, my name is Daniele. You can call me Daniele, Dan, D5E, Joke on Kubernetes. I respond to all of them. I was lucky enough to speak at KubeCon a few times. I will be in Amsterdam next week. So if you are there, please let me know. Let me know in the comments if you're going to be there and if you want to meet. I teach Kubernetes. That's my day-to-day job. I create content around Kubernetes and generally just study and try to make this technology simpler to understand. And then the goal for today is, so this is the last session on Kubernetes multi-tenancy. So in the first session, we had a look at what is the spectrum of the different multi-tenancy options that you have in Kubernetes. In the second session, we had a look at GPUs and how they break all of the assumptions that we make when we use multi-tenancy in Kubernetes. And then today, we're going to have a look at policies, and we're going to have a look at how policies sort of make everything either easier or harder, depending on what you're trying to do. Now, to get to policies and to get the multi-tenancy, we need to understand that, generally when you have a collection of servers and then you install in Kubernetes, then what happens is we actually look at this set of servers, set of machines, and we call them generally a cluster, right? We don't really mind what kind of machines are underneath this cluster, are running as part of this cluster. The only things we care is that these workloads that we have are actually deployed in the cluster. So this is most of the time the kind of abstraction that we want to provide to the users that are consuming these servers. Now, of course, this is an abstraction, right? And at the end of the day, these workloads needs to be deployed inside servers and need to run inside servers and compute. And one of the things that we do with Kubernetes is we sort of assume that we have some objects, some resources that we can use to actually group these resources into logical buckets, and these resources those resources are called namespaces. And you might think these namespaces are actually a way to isolate slices of your cluster. But that actually is not necessarily true. But let's have a look at why, and why is this so important when it comes to Kubernetes. So the namespace, what it is, all it is basically is a name. When you basically apply this namespace to the Kubernetes cluster, basically the request will go through the API server and will be stored inside etcd, the database. But once it's there, pretty much, well, no, apart from that, nothing else happens. And when you create a namespace, then this namespace is actually a logical grouping of resources. So it doesn't actually force any of the workloads to be on the same node, or it doesn't actually look at any of the part of the infrastructure. So this grouping of resources can be placed anywhere inside your compute unit, inside your worker nodes. So why is this important? Well, because you could have workloads sharing the same node, but being different namespaces. And why is that a problem? Well, it is a problem because sometimes you're not able to isolate workloads. So you might have noisy neighbor, for example. In Kubernetes, we don't have ways to constrain I/O, for example, or bandwidth. So if there is one workload which is using all of the bandwidth from the node, then the other will starve. Now, how does this namespace integrate with the rest of the cluster? So it's important to have a look at what happens when you deploy a pod, right? You create the deployment, this deployment goes through the API server just as the namespace did. And then this time what happens is the controller manager will pick up the change, will notice that the pods are missing, will create the pods, store them in etcd, and then what will happen next, the scheduler will actually kick in. And when the scheduler kicks in, we will basically look at what kind of nodes are can accept those workloads, and it will basically just filter out the one that are not cannot accept the workloads, and then it will score the rest and will score from the best to the worst. At the end of this process, then the pod, a binding will be created, and the pod will be allocated to a specific node. What's important to sort of understand is that at the end of this process, that the scheduler does not understand namespaces, as in it doesn't look at namespaces. It's not looking at namespaces. Oh, I need to put the same workloads in the same namespace in the same node as everyone else. Actually, all of these hints are something that you need to provide on top. So the scheduler by default doesn't actually understand that this logical grouping needs to be isolated in any way. Now let's have a look at something else. So when we send requests in to the API servers, generally these API servers, we talk about the API server as a block, but in reality, what this API server is a sequence of steps where we sort of check and augment what the request that is coming through the cluster. So usually the first two blocks are authentication and authorization. So the authentication block will basically just look at the request coming in and will say, is this user or is this entity allowed inside the cluster? And then the second step is actually authorization. So you're allowed to enter, but what kind of access, what kind of permissions do you have? That's the authorization part. And usually at the end of this process, then you have some info about your user attached. And then what you do next is you basically go through the permission part. You will go through what we call RBAC. And RBAC is basically where this permission will be checked, and if you're allowed to create pods or delete pods, then your request will go through. So why are RBAC important when it comes to multi-tenancy? Well, generally, you can sort of define roles, and you can define rules for what is possible inside these roles. So I can write, or I can delete secrets, or I can create them, and so on and so forth. And this role, actually, they work on namespaces. So this is one of the first things that we see, and it works with namespaces. Well, apart from cluster role, of course, that are cluster-wide, then in general, these roles are namespaced and work with namespaces. So these namespaces actually and RBAC, they work together. So for the first time, we see some combination of the two, and we can see how this isolation works. But at the same time, this permission, they are only sort of related to the API server. But the good thing is I can combine these permissions with something else. So this is a resource quota. So I'm basically defining resources that can be assigned to a particular namespace. So how does this work? Does it work across different nodes? Yes, it does. And is the scheduler aware of it? In a way. So let me explain how it works. So generally, when a request comes in, we need to be able to say, hey, this pod is too big and it doesn't fit in your allowed quota. But where do we have this data about how big is the pod, what is the quota, and so on and so forth? Well, it turns out that we use the definition that are stored inside the workloads to understand how big they are. So we look at requests, we look at limits, and then what we do is we actually use something called the admission controllers inside the API server to actually check these constraints and verify if these requests can go through or need to be rejected. So inside the API servers, there are two blocks, the mutation and validation admission controllers. They will basically go through a series of checks for how the request is coming in. And one of these checks, for example, when it comes to mutating, is the resource quota. So for validating is the resource quota. What it means is that if you try to create a resource, then inside the API server, this resource will be inspected. Then from the database, we can check who was the quota assigned from this namespace, and then we can merge these two information and basically decide if the request should go through or should be rejected. So this is how we can reject before the workload is stored inside the etcd, before the controller can see it, and before the scheduler can allocate it to a node. But again, I could sort of forget to set requested limits in my container, and in that case, then the request, apologies, the request will just go through. So a good example is I don't put requested limits, then the Kubernetes, there is no problem with the size, and the Kubernetes scheduler will place it anywhere. The other example is limit range. So I can say, by default, the size of a workload is this much. And then if you don't set it, then I will set it for you. Again, where does this live? Well, it turns out that this lives in the mutation admission controller, where we have something that can mutate the shape of the YAML and make sure that if something is not set, then it will be that particular size. Now, if we step back and we look at what we've done, there are some sort of patterns that are emerging. So these namespaces, they don't actually help us allocate workloads together. They are good at grouping. We know that we can use permissions to assign things to these namespaces. And then we know that we can attach stuff on top of the namespaces like limit ranges and resource quota, and all of these lives on top of this very simple logical grouping of things, so a namespace. But we notice that the namespace doesn't help us with resources, it doesn't help us with scheduling. We'll see in a second how it doesn't help us with networking. So the only things that it really does is basically permissions. And then networking is the same, is another problem, right? Because when you place these workloads, there is sort of nothing in this namespace in protecting you from having pods talking to other pods inside the cluster, even if they belong to different namespaces. Actually, this is the first Kubernetes networking rule is that all pods can communicate with all other pods inside the Kubernetes network. So it's a flat network where anyone can talk to anyone, even if they are in different namespaces. So what do we actually do with this this problem? Well, generally, so the pod-to-pod communication, by the way, is basically it's a flat network where I can have one pod going from one side to the other. And it's not aware of the namespace. So one of the things you usually do is we use something called network policies. And these network policies are basically a way to describe how the traffic should flow inside the cluster. But even in this case, the way they work is basically they work on top of namespaces. And so this namespace, this grouping is basically helping us sort of define how policies are applied inside the cluster. So they're basically just like a way to define a set of things and a way to define sort of policy around this grouping of things. Of course, network policies can have different targets, but I think this is where we're coming from. I think this is the interesting part, perhaps, about namespaces. So we know they don't isolate anything, but actually they are a building block for other components that can sort of help you with isolation. Okay, so that's the message that we I wanted you to take across. Now, the other thing is, so most of the time this is good enough, right? Maybe you work with a team of engineers, everyone trusts each other. Maybe you work with several teams, and you often talk and have discussions, and you trust each other, and everything is fine. But what you need to remember is that if you're all using the same server, then this grouping, these namespaces, they are basically just helping us group things. They don't really isolate any of it. So if someone is abusing of this cluster, intentionally or not, then things eventually will bubble up, and someone will pay the consequences. So what if I don't want to share? The problem with this not wanting to share comes down to the fact that we don't want to share these APIs. So namespaces live inside the API server. So what we are trying to do is we don't want to share this API server. So how do I not share an API server? So if you join me in the first session of this series, we talked about different sort of options that you have. So there are simple options, so namespaces, which we had just addressed. There are some more polished version of namespaces, and then there are several more complex solutions that you could implement based on your appetite for isolation, complexity, and day two operations. So we talked about namespaces now. We explained how the API server works and how these namespaces are just grouping or logical things. But you could have something like, for example, vCluster or K3K for creating dedicated control planes where you have an API server for each tenant. And how does that help? It helps because you have a dedicated API server, so the isolation that we used to have before just on top of namespaces now is basically isolate as a completely isolated control plane. Again, in the previous sessions, we also talked about how choosing an isolation is just one step of what you want to do. And the next step is isolation of workloads, so what kind of isolation you want to do. And the third one is basically policy. So those were basically the three axes that we discussed. And then the third axis is actually policies. So policies are basically just like, okay, I've got my cluster. I decide how to slice it. Maybe it can be namespaces. Maybe I need to isolate this API server to be a dedicated API server per tenant. And then policies are basically just describing how do I control how the access to the cluster, the policies I have inside the cluster, and maybe also things like egress, traffic going outside of my cluster. And I think a good example of this is very simple, but also sort of very complex. Is I have a team. I have maybe several teams, and I only want to allow downloading images from a private registry because I don't really trust Docker Hub. I don't really trust external registries. Something could be infiltrated in those images, and I could pull those images, and then something which is not pleasant could eventually enter in my network. Now, fair enough. So if this is your intent, what you want to do is you basically want to block all the requests that are not coming from the registry. How do we do that? Well, it turns out that all of these policies live inside the API server. So one of the things you could do, so one of the options you have, so we talked about how these validation admission controllers got like several steps inside. And then one of these options that you have is this validating admission policy. I mean, this is one option. You have so many. And then validation admission policy is basically just a way, native way now, to describe to Kubernetes what is allowed or not inside the cluster with some cluster rules. And in this particular case, I'm saying if it doesn't come from registry internal.io, then you should reject it, right? So I can submit this request to the cluster and it's job done. Whenever a workload is created, then we talked about how this request goes through the API server, goes through authentication, authorization, mutation admission controllers, and then validating admission controller. And in the validating admission controller, then this check will be executed, and we will basically detect that the registry is a violation. But here is where things can become more interesting, right? So you have a second team, and that second team is a team which is doing machine learning, and they are doing machine learning on GPUs, and they really need images from the NVIDIA registry. That's how it works. And they trust it, and this is signed off, and they can do it. So what do you do next? You have a few options, right? We talked about how these, in this case, we're using a single cluster. So we have a single API server. So what you could do is you can go back and change the policy, right? And relax it for everyone. So every team is allowed to do both, to pull from the internal registry and to download from NVIDIA. You could add an exception. So you could say only the team coming from this namespace can do this NVIDIA, pulling the NVIDIA images. And this is okay. This is probably doable, but now you start having like exceptions on who is running, what. And this could become problematic as you add more teams to your cluster. Or you have another option, which is like, okay, I actually don't want to have this problem. Then what do I do is I am solving this problem with namespaces, but I can move to the right. And if I move to the right when I slice my cluster, then I could have this tenant to have dedicated control planes. So, and suddenly I open up the space, I open up the possibilities of things I can do with my cluster, because if each tenant has got a different control plane, then suddenly it's a lot easier to just have policies. One policy is dedicated from that control plane, right? And then I'm sort of drawing here the sort of tools that are in that space, but this is basically just your choices. Is basically saying, okay, what kind of trade-offs am I trying to solve, and what kind of cons I'm going to have if I adopt any of these options. But here is the interesting thing, is that by moving to the right, then I solve the problem of policies, but I introduced a new one. So let me show you first what happens. So instead of having a single cluster, then I end up with two control planes, right? And then each policy, each team can have their own policy, their own rules. But the problem I have right now is that, okay, good. There are no exceptions. It's all good. But when a new tenant comes in, who creates a new policy? You need to remember to create a new policy. And then who is keeping track of all the different policies? If one changes, do I need to update the other? Before I had a single policy, but now I have one per team, one per cluster, basically. And then how do I do auditing, right? So I've got a proliferation of policies because I have all of these different control planes. So this is where basically the tension comes from. And the tension is that you could solve this in different ways. At the end of the day, is all about trade-off, right? So one way to solve this, it would be to have like a nested control plane. And what do I do is whenever with nested control planes, the actual control plane doesn't have nodes, but there are techniques like what is used in vCluster and K3K, in which we can basically move this pod from one control plane to the other. And when we do that, then who is creating the workload is not the nested control plane, but the actual cluster, so the main control plane. And if we do that, then but how does that work? Then generally, what happens is there is a controller in the main in the main cluster, which basically does all the syncing for these different resources. So the idea is that your user, they use a nested control plane. All the requests go through the nested control plane, and then there is a controller that will basically look at a controller or some other binary that will basically do a sort of syncing between the two different control planes, and eventually these resources will belong to the parent control plane, and will be created there. If we have this mechanism, then what happens is the admin can actually do also the opposite. It can create a policy inside the parent cluster, and then we'll have this policy pushed to the next control planes. And if you think about this is actually different from having like separate cluster, because everything goes through the main cluster and then it's pushed to the others. But the other thing is, I don't need a control plane. I could also use something like, I don't know, Argo, for example, to do the same thing. What problem am I solving there? And what I'm trying to say is that, okay, you could have, of course, you could have all the policies on and submit them manually to every control plane. But if you use a solution, a multi-tenancy solution, which works with nested control planes, then you have options to actually organize these policies in a central location, which gives you some advantages. Of course, the other option you have is to actually create a central repository and then having a way to distribute these policies. And this works not just with nested control planes, but also with separate clusters as well. So which one should you choose? Well, I think that's basically where the real question is, right? And to explain that, let me show you something else. So the other things which you want is separation of networking. And when it comes to networking, generally what we want to do is we want to segregate workloads. But again, this is also something that comes down to, okay, what kind of technology are you using? How are you slicing your cluster? Are you using namespaces? Then you might be in troubles because these namespaces don't actually offer any sort of network isolation. But what you can do is to actually use something like a node selector. So, you can use something like a node selector, for example, which lets you position these pods in dedicated nodes. Now, this is still not good enough, but it's actually a good step in the right direction, right? Because if there was a way to actually have dedicated nodes for workloads, for teams, then and we could isolate them, then it would be problem solved. Well, it turns out that if you move right to the spectrum, right, and you move away from namespaces, then there are solutions in which we can segment the network either by just doing using the same mechanism where we have a nested control plane, or what you could do is you could have, like, again, nested control planes, but every team brings their own nodes. And in that particular case, what happens is they just attach these worker nodes to a specific control planes, and all the networking is isolated between the nodes. So there is no way that these workloads can talk to each other. So why is this important? It is important because a different sort of moving left or right of this spectrum gives you like different way of isolate things and gives you different trade-offs, essentially. And the other things, and the last thing I want to discuss is that, yeah, when we talk about policies, I think it's just, at least in my mind, I always assume it's policies for security, right? Or for something, I'm going to do something nosy. Let's fix that with a policy. But I think policies are not just security. And a good example of that is that there is a trend, more of a trend like a need to control spending in your cluster, right? And a good example of this is the descheduler project, for example. So the descheduler project is something that you can define policies, and these policies are, of course, going through the API server, stored in SED. They apply to namespaces, and what you can say is that if this node is overutilized compared to the others, please delete this pod, please move this pod to a different node. And then you can have basically this scenario where a node is overutilized and a node is underutilized. And then the scheduler will basically look at the policy and say, okay, I'm going to try to even up this utilization. Of course, you have like different ways to define this, and this is not the only tool that exists. There are many sort of proprietary products that do things similar, and even more than that, they also play with requests, limits, and they give you insights on what's going on, and they can also adjust these limits and requests on the flight. So why do we have? So why is this policy different, and why it's worth mentioning it? So we talked about how policies on networking for isolating workloads is actually easier as you move right, because you have nested control planes, you bring your own nodes, you have separate clusters. So as you move to the right, these become easier, right? But with resource optimization, it's actually the opposite problem, right? Because if you have just namespaces, you're basically sharing all the hardware, and it's much easier for the descheduler to just look at all of these existing workloads and decide where the optimization should be, and is working across a large number of nodes. But as you move to the right, things becomes a little bit more complicated. And then the reason is because each team gets their own nodes, for example, or their own cluster. So there is a limited number of changes that can be done when it comes to optimization. Now, all of this is for saying that, yes, you have options for policies. You can go very, very simple and start with namespaces, and then you can move to the right if you want more isolations. But at the same time, applying policies when moving to the right, it becomes easier for certain things and harder for others. So there is no like solution fits all. So which one should you choose? So I think it's not easy. I reckon it's not easy. But I think when I think about this problem, what I'm trying to sort of focus on is that Kubernetes is designed for sharing. Okay, so most of the time you don't want to fight that. Of course, there are times where you have to, but you sort of try to embrace that. Now, the other things you need to think about is how Kubernetes works with these objects and what kind of isolation is provided for you, if any at all, and how that isolation works. Now, for us, that basically goes back to how are these namespaces working? They're actually just something that we find inside the API server. So the API server is important to us because it does a number of things. If we want to create things on top of namespaces, we need to interact with these API. And if we want teams to have different sort of behavior from this API, then what we need to do is to basically separate, have each one having a different API. Now, the problem with different APIs is that they all store different objects, right? And the problem is who is creating these objects, where is creating these objects, and who is updating, who is checking that they are up to date. So all of these problems actually compound as you start having more control, more API server, or make more control planes in your infrastructure. But we just saw how moving to the left or moving to the right in the spectrum actually gives you different trade-offs. So you have all of these problems creating, updating at a drift because you're moving to the right. But as you keep things simple, then things are a little bit easier, but you have very little flexibility. Like in the case I just showed you, for the two teams that are sharing the same policy, and one of these teams is trying to download images from NVIDIA. So the bottom line is, unfortunately, there is no magic bullet, and there is always like a spectrum of options. But I think what is important to take away from this is that you can choose the best option for you, right? Which might be, at the very end of the right of the spectrum, or maybe somewhere in the middle, or at the very beginning. I think it all comes down to, sitting down, understanding what your team needs, what are the constraints, and how Kubernetes works, and then, putting the piece of the puzzle together. That will give you the final answer. I talked a lot. I hope you enjoyed and find it helpful. I just want to thank you for staying with me till the end. I want to thank you, Vcluster, as well, for having me. This has been the third episode. It's been 4 weeks. I really enjoyed, and hopefully I'll see you in KubeCon. I'll see you in KubeCon, Rahul.
Yeah, thank you, Daniele. This was great, and a marathon of like 4 weeks. We started with, or rather, you started with establishing the 2026 spectrum. Then we went into GPU multi-tenancy. We also, by the way, showed Mike and Bill from Vcluster team. They showed this demo of Run AI, Vcluster on AWS. And of course, I will send out the recording. And to end the series, we ended it with the enforcing policies. This was amazing. And as you're showing here on the screen, next week we are at KubeCon. Vcluster will be at KubeCon. Daniele will be at KubeCon. And on day 0, we are doing this hands-on workshop, Kubernetes Platform Blueprint. And if you haven't registered for that yet, please do. I will also send that in the email. But yeah, any closing thoughts, Daniele?
Not really. I'm actually very, very, very excited to see what will be the keynote for KubeCon this year. I think there's been quite a lot of focus on AI in the recent past. I think it's getting more traction as well. So I would expect that to be the case for this year as well. But yeah, definitely interested in that. And then also quite interested to see what we will see when it comes to observability and what the vendors are doing between AI and observability. I've been seeing quite a lot of progress in the space, so I'm really interested to check out what is the latest there.
Yeah, same here. And I'm just coming out of NVIDIA GTC. Actually, it ends today. I was there from Monday to Wednesday, and there has been some exciting announcement and stuff. It's the space is really hot. So let's see how the CNCF ecosystem next week. The announcement.
It's going to be all about OpenClaw.
Open.
All about OpenClaw native.
Yeah.
Anyway.
All right. Thanks everyone for joining. This concludes our multi-tenancy March series. As I said again, I will send out all the recordings, the links, how to register to Kubernetes Platform Blueprint in an email. So look out for that email. And then if we get a chance to meet next week, if you are in Amsterdam for KubeCon, definitely stop by our booth, Vcluster booth 520. Daniele will be also there. I think he has a talk.
I forgot about that, but yes, I do have a talk. I'm going to talk about GPUs as well again. So we will cover. I focus on. I will be on the beginner track talking about GPUs. So yes, probably it is still the basic. I like foundational stuff in Kubernetes. So if you're interested about Kubernetes and GPUs and how everything works, then yes, join my talk. Or Rahul is going to share my book on GPUs. the
Yes,
book I wrote on GPUs. I've heard it's been used by others to teach how GPU works.
exactly.
Um, so yeah, I will be. So my talk is on Wednesday morning, so I'll be there.
Sounds good. All right. Thank you so much, Daniele. Thanks everyone for joining. And with that, goodbye.
Thank you. Bye.